All right, CNT125, Chapter 8, Segmentation. So a network can be segmented or broken into pieces either by physically creating multiple LANs, a LAN in a building, a LAN in a building, LAN in a building, and then eventually connect them together, or logically through the use of VLANs. We're going to tackle this later this chapter, but we're kind of introducing the concept now with you. Either way we do this, the larger broadcast domain is divided into smaller segments, and the IP address space is subdivided as well. Now, we're gonna talk about this in just a minute as well. Two important ways for network segmentation. I can do a subnet, which we're going to spend a chunk of this chapter on, or I can do VLANs, which again we're going to spend a chunk of time on in this chapter as well. What we do want to remember, and the later in the chapter they tie this thought up with you, but I'm going to plan it right now. Typically, subnets and VLANs usually work together. They don't usually work on their own. We typically use them together. So the rule of thumb tends to be one subnet per VLAN equals one broadcast domain. They all basically mean the same thing. I do a subnet, that's typically a VLAN that I'm going to use, and that's going to be one broadcast domain. Well, let's tackle this broadcast domain thing here in just a minute. When I segment my network into smaller networks, the following occurs. We're now kind of keeping some of the traffic local. Think about a campus like think about HACK. Think about HACK's campus. We'll pick on Harrisburg for a minute. Harrisburg has multiple buildings. If the traffic in one building, let's just say the traffic in our networking lab, is allowed to run free, all that traffic from our lab room is going to go through the whole building, and it's going to spill over into the neighbor buildings. And again, if we don't contain it, it would spill over the link down to York, Gettysburg, Lancaster, etc. That's not acceptable. We need to break it, we need to isolate that in some way. If I keep the traffic in that building, it's not clogging up the network in other buildings. So when I segment a network into smaller networks, we are trying to keep traffic on one part of the network separate from another part of the network. And I'm also trying to keep the network be its own broadcast domain. There are protocols out there that by default are going to broadcast. If I don't stop them, if I don't contain them, again, the broadcast in our networking lab room goes the whole way through the campus and the whole way down to York, Lancaster, Gettysburg, etc. Again, that's not acceptable. So segmenting my network keeps the traffic from affecting other buildings. It also keeps particular broadcast traffic from affecting other buildings and so forth. So when I'm segmenting, when I'm breaking my network apart, I'm actually improving performance. I'm helping with security, because again, that broadcast traffic going through multiple campuses, again, that's kind of like me yelling out here's my Visa card number. I'm yelling that out through the network. That's no good. And it's also going to help with troubleshooting, because if it's affecting a building, it's only affecting that part of the network, that segment of the network. Networks are commonly segmented by one of the following groupings: geographic location, department, or device types. Geographic location could be a floor of a building, or could just be a building. Departmental boundaries could be certain departments of a network. It could even be certain populations of a network: student, teacher, visitor, that sort of thing. Could also be by device type. Printers and desktops are separated, wireless users are separated, IP phones are separated. I might do it by device type. And it actually might be a combination of a couple of these things too. You might break it out that way. And again, all those are in the name of trying to do this and enhance security, performance, and help with troubleshooting. That's the name of the game there. Well, let's tackle this broadcast domain thing. And to do that, we also need to tackle collision domain thing. As I always say, these are terms that you should be familiar with, and the network and how it's built is going to be evidence of people understanding these. But the reality is, you're probably not going to be sitting around the lunchroom going, "Hey, how about those collision domains?" It's just not going to happen. But I need to be aware of them, because this is how a network is built. The way it's built is addressing these issues. So a collision domain is an area of a network where a collision can occur. When I don't have any devices with intelligence to control traffic, collisions can occur. So back in the old Ethernet hub days, while there was a hub there, the hub repeated everything. Well, the hub could repeat data and cause a collision with somebody else. So that whole hub area is one giant area of the network where it's literally, almost causing collisions. That is going to clog down the network. People are going to have to back off, wait, resend. So the throughput there is going to be very, very low. The throughput's going to be very, very low. So by adding something with a little bit of intelligence, things layer 2 or higher, that's a little bit of intelligence, we can minimize or reduce the area where collisions can occur. And this is actually a good thing. The more smaller collision domains that I make, the more of them that I make, that means the smaller they are, the smaller the number of things that are competing for the bandwidth, and the less things that are competing for the bandwidth means less things are going to cause collisions. So if I make many small collision domains, those devices in there, the chances of a collision, get less and less and less to the point where you may not have a collision at all. And when that happens, we're not sharing, we're getting full throughput or through bandwidth, if you will. So if I look at a network where I have a hub, this hub right here is layer 1. It's going to send data to whatever it receives, it's going to send to everybody. So all of those things in there potentially could have a collision. So therefore, all of them are sharing that available bandwidth. So the throughput there would be extremely lousy because it's sharing that. Because it repeats everything, it's sharing that. Meanwhile, if I have a switch, like I have here, the switch is a layer 2 device. It's going to try to send data to one device or one port. And because it's doing that, each device and port is essentially its own collision domain. It's not competing or sharing with anybody. So the likelihood of a collision is essentially nil. So now we are getting full throughput, almost dedicating the full bandwidth to each of those ports. And that's because it is a very small area, basically one computer, that is getting the bandwidth. It's not sharing with anybody. It's not colliding with anybody. So when I add in something layer 2 or better, I'm making many small collision domains, which is good. Each of those things and each of those ports, each of those devices is going to get full throughput, full bandwidth, if you will. So collision domains, putting in switches, which many networks did in the early 2000s. Many did in the early 2000s. They replaced all their hubs with switches. So that allowed almost full throughput to every node, every device. That's a good thing. Broadcast domain, an area where broadcast can propagate is called a broadcast domain. And if I don't have anything with higher level intelligence, layer 3 or higher, nothing is stopping this broadcast. Switches don't stop broadcasts. But something layer 3 like a router or higher is actually designed to say, hold on, where are you going? What are you trying to do? It's going to stop those broadcasts from traveling. So anything layer 3 or higher, including VLANs, which is why we're spending time on this, including VLANs, they are designed to contain those broadcasts. So if I put a router here, a broadcast in this part of the network will hit the router and the router is going to go, no, stop. That is helpful. Again, think about Hacks Campus, York, Lebanon, Lancaster, York, Gettysburg, okay? With a router at the edge of a campus, none of those broadcasts are going to leave the campus and go across to the other campus, York, Lebanon, Lancaster, etc. Okay, so the router is going to contain those broadcasts. Well, that can also be done with a VLAN, which we're going to spend time on later in this chapter. So, again, this is a good thing. I do need to contain my broadcasts at some point because some protocols will broadcast by default. So here in our example, I have a layer 3 router up here. It's not going to forward broadcast between its interfaces. It's going to contain them. So it would contain them to maybe this floor, this room, this building, and not allow it to go to another floor, another room, another building, if you will. All done with our layer 3 device or VLAN. Layer 3 device or VLAN. So when they talk about segmentation, I take one existing giant network or giant broadcast domain, and when I break it into subnets, using, layer 3 subnets or VLANs, I'm taking that giant network, that giant broadcast domain, and breaking into smaller pieces. And the name of that is again, as we back up here a little bit, the name of this is for improving performance and helping with security. And with that, that also helps with troubleshooting, because I know it's affecting a certain floor or a certain building and nobody else. I know there is where my problem, I'm going to start troubleshooting. That's the idea of this segmentation. So as we move on through this chapter, a lot of the ideas we're talking about are, how do I take my network and break it into pieces for those reasons? Subnets and VLANs are the big things we use, subnets and VLANs. So here I have a single LAN or broadcast domain, all these switches here into one router. So in this case, a computer here, if it sends data, it can reach anybody in the network. If it broadcasts, or a certain protocol broadcasts, it's going to go to everybody in this building, all floor 1, 2, 3. So to help make that better, I could have each of these switches on the floors connect to a router, and the router now makes each one of these their own little mini network, each their own little subnet, each their own little broadcast domain. So now this computer here, through the assistance of the router, can talk to a computer on another floor, but the computer here, when it broadcasts, or a certain protocol broadcasts, this router is going to stop and say, you know what, I'm not going to pass that to the other floors. It doesn't need to happen. So we're starting to improve the performance in our network and containing some of that traffic. So a lot of what we're going to talk about the rest of this chapter is, how do I do these things? How do I create these subnets? How do I create these VLANs? Okay, and they're showing you here the idea here. Again, as I do that, I have a broadcast domain here, broadcast domain here, broadcast domain here. And the router can do that. The router can do that. So subnets are going to help me with doing that. And that'll be one of the first things we tackle when we come back in the next podcast.